Hi everyone, and welcome to MathSux. This video is going to help you pass Algebra 2. In this video we're going to look at imaginary numbers, first by identifying what an imaginary number is, then evaluating imaginary numbers raised to a power, then by multiplying complex numbers. To start, let's first look at what imaginary numbers are. Imaginary numbers happen when there's a negative under a radical and look something like this. So if we had radical -1, this would really be equal to I. So the reason we can't have negatives under a radical is because square roots always represent a number times itself. So for example, if we had radical 25, the 25 would be equal to 5 times 5 equals 25. Or radical 25 can also equal -5 times -5, because it also gives us a positive 25. But notice we cannot have a -5 times a 5, because then that would be the same number, so we can't have a negative under a radical. And that's where imaginary numbers come in. So if we had radical -25, this would actually be equal to 5i, and we would put it in imaginary number form. So another thing about imaginary numbers is that they have their own exponent rules. When imaginary numbers are raised to a power, they have different values. So I raised to the 0 power is 1, so that just stays the same. Anything to the 0 power is always 1. I to the first power is I itself. I to the second power equals -1, and then I to the third power equals -I. And if we kept continuing this pattern, if we kept raising this exponent, if we did I to the fourth, the pattern would just keep repeating. So now I to the fourth becomes 1, I to the fifth becomes I again, I to the sixth becomes -1, and the pattern continues if we just keep going. So if we wanted to evaluate our question here, we want to evaluate the value of I raised to the 54th power. The way we can do this is by using long division. So let's just keep our rules right here so we can see them. And let's look at our question. Evaluate I raised to the 54th power. So what we're going to want to do is take our exponent, 54, and bring it on down here. So 54. And we're always going to divide by 4. So whatever the exponent value is of imaginary number, to evaluate it, you're always going to divide it by 4 because of this pattern where it keeps repeating every fourth term. So now we're just going to do long division. So 4 goes into 5 one time. 1 times 4 is 4. Bring it down here. We get 1. Bring it down to 4. And then this 4 can go into 14 3 times. 3 times 4 is 12. And notice we get remainder 2. So what we're going to do with that remainder, we're going to make it our new exponent value. So we had I to the 54 originally, but now we're going to take the remainder and plug this in. So this is going to become I squared. So we're just plugging a remainder into as our new value for our exponent. And now we just want to evaluate I squared. And we could see from looking over here, our exponent rule is I squared is equal to -1. So that's our answer here. Don't worry about memorizing the exponent rules because you can always plug these into your calculator. Now we're going to look at complex numbers, which are a little different. So complex numbers always come in a+bi form, where this is just a regular whole number. And then this is like a whole number b times our imaginary number, so it becomes an imaginary number. So they're not complex at all. So our question wants to multiply two complex numbers together, 3 plus 2i times 5 minus 4i. So we're going to be just multiplying this like any other binomial. So there's different methods you can do. I'm going to do the box method here because I know a lot of people like that, so let's do that. So let's draw a box with each term for each square. So over here we'll have 3 and 2i, and then over here we'll have 5 minus 4i. So now we're just multiplying these together. So 5 times 3 we get 15, 5 times 2i is 10i. Negative 4i times 3 is minus 12i. 2i times minus 4i is negative 8i squared. So now we're just gonna want to combine like terms and our solution, which is everything in this box. So notice these two can be combined. So let's write our answer. So we have 15 as our standalone number, and then combine our like terms. Negative 12i plus 10i will give us minus 2i, and then we have this minus 8i squared. So notice 8i squared, that looks familiar, right? Remember, 8i squared is really equal to negative 1. So let's plug that into our question now, our answer. 15 minus 2i minus 8 times negative 1. 15 minus 2i minus, so now we're going to get negative 8 times negative 1, which is plus 8. And now we're just adding 15 and 8, and we get 23 minus 2i. And that's our answer. And notice it stays in that a plus bi form where we have our whole number. A plus bi form where we have our whole number and then our imaginary number. And that's our answer. So take a look at this next slide that summarizes everything we just went over, including what imaginary numbers are, how to evaluate when they are raised to a power, and multiplying complex numbers. And if you're looking for more practice, check out these questions here. The answers are up on the blog, MathSux.org, so you can check those out. And if you like this video, please give it a thumbs up and subscribe. Happy calculating! Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!